All right, let's take a look at question number 5. So for problem 5, we're to determine if the function f of x is continuous at x equals 2. And this is a function right here. Now, before we determine if this function is continuous or not, we're going to go over the definition of continuity at a point, okay? What does it mean for a function to be continuous at a specified value? All right, so let's take a look at the definition real quick. Definition of continuity. So we can say a function, let's call it f of x, is continuous at x equals a if the following conditions hold. If the limit as x approaches a from the left of the function is equal to the limit as x approaches a from the right. So the left-hand limit must be equal to the right-hand limit, and both of them must be equal to the value of the function at that value that x is approaching. All right? So there cannot be any kind of discontinuity at that point. So the existence of the left and right-hand limit, and also them, both of them being equal to the value of the function ensures that the function is continuous at that specified value. All right? So that's the situation there. Now let's go ahead and apply this definition to this problem. Now what we have is we have um, two intervals and a point. Okay, so let's draw a number line. The point that we're looking at is the value where x is equal to 2. All right, so the interval to the left, let's call that interval 1. And then the interval to the right, let's call that interval 2. Okay? Oh, how about we call that 3? Now, the left-hand side to left of 2 is 1. Let's say being on the point is 2, and then to the right is 3. In this piecewise defined function, we have three functions. We have function 1, the quadratic function. We have function 2, the constant function, and then we have the logarithmic function right there. Okay? So these functions, they fit into this one of these three regions we have right here, this point of these two regions. So if you're on the left side right here, this area is where x is less than 2. At this point, x is equal to 2. And then at this interval, x is greater than 2. All right? So for this region, what we're going to be looking at is the limit as x approaches 2 from the left. Okay? And then at this point, we're going to be evaluating the value of f of 2. And on this region right here, we're going to be looking at the limit as x approaches 2 from the right. So we're basically approaching 2 from both sides, and then taking a look at the value of the function when x is equal to 2. All these three must be the same in order for us to conclude that the function is continuous at x equals 2. All right? So let's go ahead and compute all of these three values. All right, so we're going to take a look at these limits and then evaluation of this function one by one. So for region 1, we're determining the limit as x approaches 2 from the left of the function. All right, so 2 from the left, when x is less than 2, the function in play is the quadratic function. Okay, so in this region, the function that we're looking at is x squared plus 3. All right, so this limit is basically the limit as x approaches 2 from the left of x squared plus 3. All right, so this one can be evaluated with direct substitution. We have 2 square plus 3, and then that is 4 plus 3, and your final answer is 7. Okay, now let's take a look at 2. 2 is a point. We're looking at f of 2, not the limit. We're finding the value of the function at x equals 2. Okay, so f of 2 we know what f of 2 is, right? F of 2 is simply 7, because that's what's indicated here. In the piecewise defined function, when x is 2, the function assumes the value of 7. Okay, when x is 2. So we can clearly see that f of 2 is 7. It's looking good so far because the left-hand limit is equal to the value of the function. Now, if the right-hand limit as x approaches 2 from the right, if this is equal to 7, guess what? That automatically means that the function is continuous at x equals 2. But if it's not, then that means the function is not continuous at x equals 2, all right? So let's see what happens here. From the right, the function in play is your logarithmic function, log base x, actually it's 2 log base x of 64. So what we're going to be looking for here is the limit as x approaches 2 from the right of 2 log base x of 64. And then we'll plug in 2 into the function. We have 2 log base 2. 64 can be written as 2 to the 6th power. All right, using properties of logarithms, these two cancel out, log base 2 and 2. And then we'll simply have 2 times 6, which is 12. All right, so what conclusion can we draw here? We can say that since the limit as x approaches 2 from the left of the function is equal to the value of the function at x equals 2, well, both of them are not equal to the limit as x approaches 2 from the right of the function. What does that mean? It means that the function is not continuous. The function is not continuous at x equals 2 because the right-hand limit is not equal to the left-hand limit and the value of the function. All three of them must be equal in order for the function to be continuous at that specified x value. All right, so now you can move on to question number 6 or go back to the main test to gain access to all the test questions. And don't forget to subscribe for updates to other cool math tutorials such as this.